So good afternoon to all of you. This is the topic that I'll be talking on, and she gave a brief intro of myself, what exactly I do. I have a separate slide for that as well, so I'm again gonna add some more points at it as well, like apart from my tech community contribution, what else I keep doing. So this is the topic that I'll be talking on, IaC meets Python, when Terraform is not enough. Okay, so this is about me. So my name is Rajani Ekunde, and right now I'm working with Okta, if you guys know. I'm working there as a senior site reliability engineer. And before Okta, I used to work with Global Logic for 2 years. And apart from this, I am a Docker captain as well. So Docker is one of the most important tools that we are having when it comes to DevOps ecosystem. So I'm a Docker captain for, basically they selected me for this role for my contribution in the Docker community. And I am WT ambassador, so this basically revolves around how we can involve more women participation in these kind of tech conferences. Okay, right now I can't see any women here, only one volunteer I can see. So that's what we are doing in this WTM thing. And I'm an international speaker. I have been to US multiple times for speaking, and I'm a left scholar as well. So any one of you is either interested in doing any kind of Kubernetes certification. So this scholarship is really very cool because you'll be getting a free voucher for the certification. So you should definitely check that scholarship. So this is about myself. Okay, so let's move forward with the topic that I'll be talking on. So nearly 70% of the Terraform deployments basically fail when we are applying them at the first place. Okay, so this is a very basic scenario. Like most of the times, even I have not 70, but I face this 90% of the times. Like every time I'm applying my changes for the very first time, it definitely gonna fail. There can be many reasons. Either it can be some kind of misconfigurations that you have done, or your infrastructure basically is missing some kind of dynamic data. Either it can be due to like your infrastructure requires some kind of API responses on the go, and that basically generates when your application is running. So in these kind of scenarios, of course, your Terraform apply is gonna fail. So that is one of the major challenges that we face. I face this on a regular basis. So this is the agenda we are having. What exactly is gonna be my talk about? So we'll talk about why exactly we need to go ahead with IaC. The full form says infrastructure as code. And what are the strengths of Terraform we'll talk about. Then what are the limits of Terraform we are having. Then why exactly we need to go ahead with Python, which we'll talk about, and how exactly Python is gonna extend the power, or how Python is gonna basically override the limitations of Terraform. We'll talk about that. Then I have a demonstration as well. Like in real time, we'll be saying how we are enhancing the Terraform power by making use of Python. So that architecture I'm having, and demonstration we'll see, and then we have best practices. So this is gonna be the flow of the talk. Okay, so why IaC matters? So anyone here would like to talk 1 or 2 lines about what exactly is IaC? Do we have anyone? Okay, cool, no issues. Oh, yes, go ahead, please.
I only did a little bit, but like you write that file and then it says what you want to deploy, and then you
exactly.
and it runs it on AWS or something.
Right. So why IaC matters? Like we can consider, I'm going to give you a real life example. Like suppose if you are having application with you, and your job is basically to deploy that application into the cloud. So when it comes to deployment, so like a lot of things we have to do. We have to run the servers. If your application requires DB, then we have to configure databases, the networking thing. A lot of things are going to be there. And suppose if you have very less time, or you are not willing to go forward with a manual approach to create this entire infrastructure manually. So to overcome that, we have this IaC, infrastructure as code. So whatever things you require, either you need a server, you need a database, you need the networking configurations. So these are all things you can basically write into a script, and that script you can quickly run using 1 or 2 commands. And once you are running that, you'll be having your entire infrastructure ready. So that exactly what IaC is doing. It's basically automating your task of creation of the infrastructure, and Okay, first, so of course, like automation is gonna be there. Also, versioning is gonna be there. You can keep a track of what exactly is the current version that you are using and what different changes you are doing in the next version as well. So it's gonna support versioning. And again, scales infra as well. Like suppose on the go, you are receiving a lot of traffic on your infrastructure. So if we are going ahead with scaling the application in the manual way, so again, we are having a lot of restrictions there. But if we have made use of IaC or the Terraform script for the infrastructure creation, scaling is gonna be a cakewalk there. And we are having multiple tools in the market for IaC. We do have Terraform, that's one of the most used tool for infrastructure creation. We have CloudFormation, which is basically AWS Cloud is providing CloudFormation, and we have Pulumi as well. So these are different tools available in the market. And the benefits, of course, consistency is going to be there because based on the requirement, what we can do, we can create the scripts and we can treat the scripts as templates, and whenever the same kind of resource requirement is going to be there, we can take that script only and we can run it. So you will be getting consistency throughout your infrastructure and repeatability, of course. Like number of times you need the infrastructure to be created, you can easily go ahead and make use of the same scripts and you can create the same infrastructure. And of course, suppose if you need some changes, you can quickly go and just make those changes into your script and you can rerun the scripts and you will be getting the new infrastructure. And auditability as well. So you can keep a track of what exactly is the change made and when was the change made and who exactly made that particular change into your infrastructure. So these all things will be having if we are making use of IaC. Okay, but there is one catch here. Like when we are dealing with real world infrastructure, okay, so that is always not declarative. So as I was talking about the previous slide, so how we are basically dealing with when it comes to dynamic data we are having. So that is basically gonna be a real trouble here. So that's the drawback we are having. We're gonna talk more about that as well. Okay, so first we'll talk about what are the strengths of Terraform. So of course, Terraform is providing us declarative syntax, and we can basically decide what exactly I want to be created in the infrastructure. So you need to have a desired state in your mind, and once you are done with that, you can basically go and write the Terraform wiki. This is the server I want, these many servers I want, and these should be the names. In this particular region I want these servers. This should be the type of the server. So everything, whatever, not just the servers, but apart from that, whatever resources you need. So you can basically write everything into that Terraform scripts, and you can basically plan and then apply. So in plan stage, this is really very interesting feature Terraform is having. So when you are doing Terraform plan, okay, so it's gonna tell you what exactly is the change that you are making into your infrastructure. Either like you are adding more servers, you are adding databases, you are making some change. So everything you can see here in the plan stage, and once you check that plan, okay, this is the desired thing that I wanted, then you can go ahead with the apply. So this is how Terraform is working. Then another strength we have is provider ecosystem. Okay, so basically the number of AWS cloud providers we are having, whether it can be AWS, GCP, Azure, or different tools we are having in the market for different DevOps operations. So when it comes to integration of Terraform with these different cloud providers or the different tools, it's very easy. So that's another strength we have. And community modules and state management as well. So of course the Terraform community is very active, and people are always ready to help you guys out. Like if you are stuck somewhere or you are planning to like perform some kind of experimentation, so that is available. Then we have this modules as well. So using modules, you can basically keep your infrastructure or keep your code separate. Like this particular thing is only for the servers, or this is for the infrastructure. So that is again very important here. And state management as well. So once you have created infrastructure, so your state files again will be stored, and these will be really very important when you are basically going ahead with the deployment of another version of the infrastructure. So state files are again really great here. And one more strength we have is immutable infra mindset. So Terraform is basically dealing with immutable kind of infra mindset, because suppose if you have created the infra, and now basically you need to go ahead with some another version of the infra, but there are some things which are which you don't want to change. But Terraform supports if it's possible, you either instead of going ahead and updating the same infrastructure, we can destroy and we can recreate. So that is the mindset that Terraform is following. Okay, so but of course it has a lot of limits because that's what the topic says, my topic, how we are enhancing the Terraform's power. So what are the limits we are having here? So poor at complex logics. Okay, so when it comes to you are dealing with a really complex infrastructure creation, and you have to go ahead with some loops or some conditions or the dynamic data processing. So when it comes to dealing with these kind of data and these kind of different operations, Terraform is not enough there. And again, it's gonna restrict event-driven automation as well. So nowadays, even if we are going ahead with automation, okay, so people are preferring why can't we go ahead with event-driven, so that we are again like eliminating a lot of manual intervention there. So whether it comes to like you are dealing with Lambda functions or Google Cloud functions we are having, or you are basically targeting some AWS Cloud Watch notifications, and using that you want to basically trigger your infrastructure creation and whatever different operations you are willing to. So that is not supported here in Terraform. Event-driven architecture it's not going to support. Then again, when it comes to error handling and orchestration, it has a lot of limitations there. And this is one of the examples which Terraform can't support. Okay. So suppose if you have some scenario like we need to run a cleanup job if your DDB table has less than 100 records. So this kind of logic we can't implement in Terraform. So that is one of the restrictions we are having. Okay, so now we saw what are the strengths of Terraform, we saw the limitations. So why exactly we need to go ahead with Python as a solution, or Python as one of the thing which using which we can basically tackle the limitations of Terraform. So first point I have here is imperative, flexible and API first language. So of course in the limitations we had like how Terraform is not going to support the dynamic data behavior, dynamic data processing. So using Python, we can basically override that. And of course, Python is a programming language, so we can make use of different loops. We can make use of different functions. So the previous scenario, which where I was like implementing something like I need to run a cleanup job if DDB table has less than 100 records. So these kind of operations we can very easily implement using Python because we are having features like loops and functions and everything. So that's one of the reasons. Then again, the ecosystem of Python is really very like rich. We have Boto 3, we have request, we have click, we have JSON, asyncio. So we have multiple basically additions to the Python ecosystem. So using which we can enhance the overall power. Then again, when it comes to DevOps and software engineering, okay, so DevOps is basically something which we are creating, like we have application and we basically need to deploy the same. So this is what the DevOps engineer's job is. But again, software engineering is a different part we are having. So if the requirement says that we need to integrate these two scenarios, so of course with Terraform this is not possible because software engineering basically is more kind of a backend thing, or we need to go ahead into more deeper of the what exactly the application is doing, how the application is behaving. So using Python, we can create this bridge between the DevOps ecosystem and the software engineering ecosystem. So that is another reason we have. Then IaC plus Python is definitely going to be a dynamic and programmable infrastructure, because only going ahead with Terraform we had a lot of restrictions and the limitations. We saw that. But if we are basically combining Terraform and Python, we can definitely go ahead and make use of this dynamic infrastructure creation. So that is the reason. Any another reason, if you can think of here, if anyone have ever worked as a DevOps or SRE or a cloud engineer or a software engineer as well? Anyone? Yes? You have something to say?
Only a little bit.
Okay. Okay. In India, basically, if we are, I give a lot of talks. So whenever I ask these questions, of like, people are like, I'm going to answer this, I'm going to answer this. This is how they behave. It's fine. Okay, so we saw why we are choosing Python. So now we can see how exactly Python is extending Terraform's power, or the limitations, how it's overriding the limitations. So this is a table I had created using ChatGPT, of course. So first use case we have here is complex conditionals, okay. And when we are talking about Terraform, so of course I was talking like how it's not going to support the loops, the functions, the different kind of features we are having. So Terraform is not going to support that. But of course, Python is going to support the different complex logic that we are having for the infrastructure. Then dynamic resource creation, of course. So dynamic resource creation is not supported in Terraform. For that, we have some hacks, but that is, I don't think that is appropriate or that is enough. We have hacks like we can go ahead with like adding some count or for each resource. So some these kind of hacks we need to go ahead with. But with Python, we have, of course, we have loops and we have data structures. So we can like play around a lot when it comes to creation of infra with Python. Then API pre-check. So with Terraform, it is data source limited. But with Python, we have, of course, we have Boto 3, so we can perform the API calls via that. Then post provision actions. So once, see, we are having multiple different stages when it comes to creation of infra using the Terraform. So we have to plan, then we have to apply and stuff. But once you are doing Terraform applied, so your process is gonna end there. So that's the scenario with Terraform. But with Python, Python is basically gonna handle your entire infrastructure. And again, like when it comes to recreation of the infrastructure with Python, so that is gonna be really very easy. But with Terraform, we have to again go ahead with the plan and stuff. So these all steps we have to repeat. And next use case we have is multi-account orchestration. So when we are dealing with Terraform, so we have to make sure that the state files that have been generated, so we need to store these state files into somewhere we have to store. So for that you can go ahead with for example, you can go ahead with some S3 bucket which is there you have stored as a bucket. So in that S3 bucket you can create a remote connection and you can store the state files there. So this is how we have to go ahead with, but that's a little tricky job there. But with Python, multi-state account orchestration is easy because we are having AWS SDK that is gonna handle the same. So these are some of the advanced features we can say using which we are enhancing the Terraform's power. Okay, so the demonstration which I have created is basically gonna say how exactly on the go dynamically we are creating a S3 bucket in AWS account. So this seems like a very complicated architecture, but it's very easy. Okay, so I'll explain the architecture first, then we can go ahead with the demonstration. Okay, so you can see here are the external tools that we are using: Terraform CLI, AWS CLI, and Boto 3 SDK. These things we are using basically to interact with the infra. And this is the local development environment we are having, and here is the user. So user is interacting. This is the orchestrate.py file I have created, where all the things I have mentioned, basically what exactly I want to create in my infrastructure. So everything is mentioned in that orchestrate.py file. So user is basically interacting with that file, and we are having these many different things going on in this particular orchestrate.py file. So these are basically configuration loader, variable generator, Terraform orchestrator, and AWS validator. So these all things are basically going to work as the brain right now for the infrastructure. And these are the Python components we are having, which are the brains. And using once we are done with this, we have this different another file, sub files mentioned here. So configuration.loader, we are basically configuring all the configurations which are required here, like environment configuration or the network configuration, everything will be there. And this is the DFOS file, so that will be generated on the go. Then we have main.node file, which is the definition of the infrastructure. Then we have variables.tf, variables definition, and then we have outputs.tf, which is the output definition. So these different things are mentioned in these files. And this AWS validator is basically used, see, the S3 bucket that I'll be creating, so that will be created in AWS. So for that, we need to basically validate with the AWS account. So for that, we are using this AWS validator. So this is the AWS cloud we are having. And we first have to go ahead with AWS SDK so that we can identify who exactly is the caller, basically the account owner. So this is for the identity validation. Then we are going ahead with S3 API resource validation. Okay, so in which particular region and in which particular environment we are creating the bucket. So these things are mentioned. So two buckets, first one is going to be in the def and second one is going to be the prod. And this name which you can see here, so in this format the name will be provided to the S3 bucket, but I am not going to specify any name to my bucket. so it will be generated automatically on the go. So that is how it is basically supporting the dynamic behavior. Okay, so I have a demonstration video now, because I have a really bad history of whenever I go ahead with the live demo, it always breaks on stage. So this time I'm not taking a risk, so I have recorded a video of the demonstration. Should I exit it? It's in my downloads.
Oh, you need download?
It's in my downloads.
Oh, I see. I will download it. Link function. Oh, sorry. Okay.
Okay.
Sorry. This one, right?
Oh yes. No, that is the file. This one. Okay, so this is the video. Okay, so one thing I can say here, I'm going to share the QR code. So using that, you can go to my GitHub, and there I have basically uploaded all the Terraform scripts which are required for this demonstration. So I'm going to show that as well. Let me see if I can finish this demo within time first. So on the left hand side, you can see all the different files which are needed for this particular demo, and which were there present in the architecture which I was showing. So we have config.json file, we have main.tf, we have orchestrate.py, we have outputs.tf, and this readme, and this variables.tf. So these all files are there. Okay, so this orchestrate.py file basically is gonna say what exactly is the overview we are having, what are the different features, the workflow, a lot of things are mentioned. It's a really big file. You can definitely go and check this file later on the GitHub. Okay, so once we are running this orchestrate.py file, so you can see I have basically implemented multiple things here. Like one we having is for deployment of the infrastructure, second one is for destroying the infrastructure, and then here I have the check prerequisites, and then we have the exit. So these different steps are implemented here. So out of which I'm gonna go ahead with the first option, that is deployment of the infrastructure. Okay, so I have clicked first, and it's saying infrastructure deployment, and available environments are there. Either you need to go ahead with dev, which is in region US East 1, and the prefix again demo -dev is given, or you need to go ahead with the second, that is the prod environment, and the region and the prefix is mentioned there. I'll go ahead with the first one. Okay, so after that it's saying you have selected dev environment, and now deployment summary. So environment is going to be dev, region is going to be US East 1, and the bucket prefix is going to be demo-dev. So we'll go ahead with this. Okay, so it has started the deployment. Okay, okay, deployment has been started. Okay, so you can see Terraform deployment have completed successfully. So the next stage is basically the validation one, and what things it will validate is boto 3 not available or not, it's gonna check that, and infrastructure validation. Okay, so actually when I was doing this demo, so there was something wrong with my AWS account threads. So that was the reason basically this AWS validation failed, but there is nothing related with the Terraform. So this was something like with my account thread, so that was the reason the account validation failed, but that's not required for the demonstration actually. But even though you'll see, even the validation has failed, but you'll see a bucket created in the AWS account. So again, on the below, I have again mentioned like if you want to go ahead and troubleshoot, so different things like you can go ahead and check the AWS credits, the permissions, you can verify the Terraform configuration. So a lot of things are mentioned here. So even like if you're going ahead with troubleshooting, so that also is gonna be easy. So I will go ahead with exit for here, because I'm gonna show how the bucket got created dynamically, because we had this config.json file, okay, here. So this was the file which was used when we basically started the deployment process using Python. So config.json file basically created this TF-wars file on the run, and using that we are basically getting the bucket with the dynamic name. Okay, so these are basically the, okay, so these are the files, but we can go ahead with AWS, and I'll show you guys the bucket. Okay, you can see this was the naming convention that I had given. Like if you remember, the region and the prefix I had given was demo-dev, and this is the timestamp using which, cause see, when we are creating a S3 bucket, so we need to make sure that it's having a really unique name. So it captured the timestamp and demo-dev, and it gave the timestamp, and then it created the dynamic bucket. So this is how we can create basically the infrastructure creation is going to be really very dynamic. On the go, you can make use of the dynamic data that you are receiving, and you can deal with your infrastructure. Okay, so we are done with the demonstration, and these are some of the best practices we are having. So these are only limited, like apart from this, we are having tons of best practices that we need to follow. So code separation is very important. So I was talking about modules when I was discussing about Terraform. So similar to that, we need to make sure that we need to understand what exactly is the purpose of this particular piece of code, and accordingly we need to create separation from the orchestration logic or any another, like if you want to perform any other operations as well. So that is very important. Code separation is important. Then dynamic configurations, okay, so using Python to validate and generate and extend the Terraform configuration, so that only we discussed in the demonstration. So using dynamic data is really very important, and that's gonna help us in a lot of ways. And the centralized state as well. So I was talking about one thing called as state files. So in Terraform and Python as well, we can basically make sure and we can store these state files in a central environment, because storing these state files in one central place is very helpful, because we never know like when we are gonna need the state files. So it's a good idea to store the state files in one central location. Apart from that, also like we are having a number of best practices that we need to follow. Okay, so that was the session from my side. I hope you understood like how exactly we are making use of Python for enhancing the infrastructure creation part. And if you have any questions about this session or in general related to DevOps or SRE, if you are having any questions, you can always reach out to me on LinkedIn. And if you are scanning this, you'll get a lot of options there. Like you can go to my GitHub as well. There you'll see the very first repo, which is related to this particular demonstration. So you can check those files as well. And lastly, I would really like to thank PyCon Hong Kong team for inviting me here, and all the volunteers as well for organizing such a great event. Thank you.